Okay, well, let's have a look. If we want to find out where fx is equal to gx, that's the same as saying cos 3x is equal to sine x. And bear in mind, we've got that restriction from minus 90 to 150. Okay, well, how do we do this? Well, if you think about it carefully, we want a cos on the right, so convert sine to the cos of 90 minus x. Alright, now they're the same. Then you can use the rules of trig equations. 3x is plus minus, drop the causes, plus minus 90 minus x plus k 360, where k is an element of z. Okay, cool. Now we've got two situations. The first one, and I'm going to go to a little blue color here. If we take 3x is positive, so it's positive 90 minus x plus k 360. That's the one scenario. Let's work with that quickly with the positive version there. So then 3x is 90 minus x plus k 360. Bring the negative x to the right, you get 4x is 90 degrees plus k 360. And we divide everybody by 4, which is quite nice. There's your first general solution. Okay, now what about another one? Let's go to a little reddish color here, and we're going to look at the negative there. Okay, so what does this say here? 3x, now careful, 3x is negative 90 minus x in brackets plus k 360. Don't forget the brackets here, it's the negative, and then 90 minus x. So what does that give us? 3x is negative 90 plus x plus k 360 if you multiply in. Bring the x to the left, so 3x minus x is 2x is negative 90 plus k 360. Divide everyone by 2, x will be negative 45 plus k 180, and there's your second general solution. Okay, now we want to get the exact angles or the points of intersection there. So we need to draw up a little table, and remember our restriction goes from minus 90 to 150. Okay, alright, so let's have a look here. Well, what is it? Let's go to some values for k. If we pick negative 2, negative 1, 0, 1 and 2, and then my little general solutions here, let's put them here, 22, 5 plus k 90, that's that one, and then we've got the negative 45 plus the k 180, and we plug in these k values into here. I start with 0, so 22, 5 plus 0 times 90 is 22, 5, and this one will be negative 45 if k is 0. Now if k is 1, or let's go to negative 2, that's 22, 5 plus negative 2 times 90. Now negative 2 times 90 is negative 180. So 22, 5 minus 180 will come to minus 157, 5. Negative 45 plus negative 2 times 180 is negative 45. Subtract 360, which comes to minus 405, or negative 405. Now 22, 5 plus negative 1 times 90 is 22, 5 subtract 90 gives you minus 60, negative 67, 5. And for negative 45 minus 1 times 180 is negative 225 degrees. And if we continue this way, I'm going to fill in, if you plug in 1, you get 112, 5. If you put in 2, 202, 5. This one would be 135, and this would be 315. Now, which of these angles, if you think about it carefully, would be in between here? That's out. So we don't want that one. That's out. This one's out. That one is definitely in. That one's in. That one's in. 135 would be in. 112, 5 is in, and those are out. So there's your 5 points of intersection. And you can clearly see on the graph how it works. Well, this one here would be, if you think about that carefully, that's where negative 67, 5 is. This one here would be where negative 45 is there, which is one of the answers. Then we come to here, which is 22, 5. We get to here, what's the one between 90 and 120? I think it's going to be 112, 5. There we go. And this one, the bigger one would be, obviously, I think it's 135 there. Let's see, 135. Okay, so this one would be here, would be 135. So there's your 5 angles, your points of intersection between cos 3x and sin x. What a lovely question, linking to trig equations. Okay, so guys, don't go away, stay with us. We'll be back with some more maths on Moby School very shortly.